AP Chemistry Screencast 2.10 Electrolytes. A big difference between first year chemistry and AP Chemistry is that in AP Chemistry you're always asking yourself what is in the flask. And if you're dealing with a solution, meaning something dissolved, you really want to consider whether molecules are simply dissolved or whether they've broken up into ions. After all, that's what's really in the flask. And the term electrolytes has everything to do with it. After all, an electrolyte is something that has both cations and anions in solution. Some substances, when they dissolve, break into ions, ionic compounds, for example. Some do so completely, some do so a little bit, and it's useful to know to what extent, because that tells you what's actually in the flask. A strong electrolyte means that it's a substance that completely ionizes in solution. A weak electrolyte dissolves a little bit. A non-electrolyte dissolves, it dissolves but does not ionize at all. Sodium chloride is an example of a strong electrolyte. It completely dissociates. Anytime you have a metal followed by a non-metal, you have the possibility, you have an electrolyte solution. It will be either strong or weak. And this is an example of a strong one. So what's in solution? Sodium chloride? No. Sodium cations and chloride anions? Yes, because they have dissociated in that solution. If you got a chunk of sodium chloride, what do you have? You have sodium chlorides in a lattice form. Very different. Okay, acetic acid, CH3CO2H. This can set students off a little bit. This is what it actually looks like in order. It's a carboxylic acid, and that hydrogen right there is an acidic hydrogen, meaning it can get removed, but it does so weakly, meaning that if you throw acetic acid, which is a liquid, into solution, only, I don't know, a millionth, 1 out of every million molecules ionizes, meaning that most of them do not. We call that a weak electrolyte. And some of this, you might imagine, comes down to memorization. Fortunately, there's not a lot of weak electrolytes. C6H12O6, you might recognize that as one of the forms of a sugar. And sugars, as you should know from practical experience, are highly soluble in water. However, notice that there is no acidic hydrogen here, or you could simply memorize it, meaning that this ionizes not at all. It has no ionic forms to it. There's no acidic hydrogen, and therefore this is considered a non-electrolyte. It just dissolves, but it's not salty. It does not form a conductive solution, and therefore you have a non-electrolyte. So let's memorize some. Take a guess. Strong, weak, or non-electrolyte? No, looks like we're going up here. There's not a chemical reaction unless there's a precipitate. Many times you mix things together, and they could be pairs of ionic compounds, and you're trying to wonder if a chemical reaction formed. Well, if you'd have a precipitate, then something clearly happened. Otherwise, it just ionized and everything is dissolved. So that should make sense. Anions and cations cannot be isolated. They only exist together or in solution. So you cannot buy a bottle of chloride anions, but you can buy a bottle of sodium chloride. The nice thing about these ionic equations, such as this, is that they show exactly what occurs in solution. These are always a little bit misleading to a practical chemist because you cannot perform this chemical reaction and isolate each product. You cannot do that. But you can perform this reaction and have it occur. You just can't isolate the individual substances. Okay, so a strong electrolyte could include all of these strong acids. This is pure memorization. Hydrochloric, nitric, perchloric, sulfuric, and the strong base, sodium hydroxide, which completely ionizes to Na plus and OH minus. The weak ones, boy, do these play a big role in all sorts of equilibrium calculations. This is really the real strong spot where AP Chemistry focuses and the other classes do not. The weak electrolytes include acetic acid, hydrofluoric acid, nitrous acid, notice it's not HNO3, and ammonia. They only ionize a little bit. And the non-electrolytes include methanol, sugars, glucose, sucrose, etc. There's probably lots of other substances you could come up with, ethanol, for example, that are very soluble in water, but they don't ionize at all. So memorize that which you need to memorize, understand that which you can by Looking into groups, and there you go. Tell me, is it a strong, are we going to get to this? Strong, weak, or non-electrolyte? A sugar. Very dissolvable, but does not ionize, so non-electrolyte. Nitric acid. Oh, well, we can cheat, can't we? So try not to. Whatever. Nitric acid, that completely ionizes. Strong. Ammonia, weak. Perchloric, strong. Sodium hydroxide, strong. Hydrofluoric, weak, even though it's one of the only ones that is. Look at all the H things, but that one, is weak. Water, water, what? Very, very weak, right? We'll cover that in great detail. 1 part in perhaps 10 million does in fact ionize to H plus and OH minus. Extremely weak. Methanol. I see that H, but no. Alcohols are non-electrolytes. They do dissolve, they just don't ionize. Acetic acid is weak, sulfuric acid is strong, and hydrochloric acid is strong, and another sugar type guy is non. Nitrous, look it up, it's a weak. So there's others, and there you go. These are strong, weak, and non-electrolytes.